Okay, hello everybody. We are going to pick up where we left off in Chapter 10 with types of mass wasting. We use 3 different criteria that classifies the mass movement. First thing, we look to the rate of movement. How rapid, how slow is it? Then we look for the type of movement. Is something falling? Is something sliding or flowing? And then we look for the type of material. Is it rock? Is it soil? Or is it debris? Now, if something's considered a rapid mass movement, then you're going to be able to see that movement of material. If something's considered a slow mass movement, it's really hard to distinguish that movement's actually taken place at all. Rock falls are very rapid. Unfortunately, they're also pretty common. They happen in canyons, cliffs, and road cuts. The material that you see at the base of the hill right here and all of this is what we call talus. That's that loose material that rolls down and accumulates at the base of the slope. Rock falls could be brought on by failure along joints or bedding planes. They could also be triggered by earthquakes or undercutting. Where you have a lot of mountains, you're going to see a lot of rock falls pretty commonly. So a rock fall or a debris fall, you have that vertical free fall of mass. Basically, your bedrock, your regolith, they're going to fall rapidly. As your rocks are falling down, they impact other rocks, they fragment, they break up into smaller pieces. We mentioned the talus blocks or the talus at the bottom of the hill. So you can see in this picture all the talus. Here in this one you see the talus accumulating. If you notice in this picture, states will try to minimize the damage from rock fall by putting a fencing. You can kind of see the fencing right here. So they'll put a fencing on the rock, and that way, if any starts to move, the fencing will actually keep it in place so it doesn't wind up on the highway. Another type, we have our slides. So a slide's going to occur when you have movement along one or more surface of failure. It could be between soil, it could be between rock, it could be a combination. So there's 2 types. In this first picture, we're looking at what's known as a slump, which is also called a rotational slide. You can see how this slump is along this curved surface. So basically, if you have unconsolidated or very weakly consolidated material, you're more likely to have a slide. You can see how this area at one time was up here and it's slipped down. This is slipped down like this is slipped down here. So you can see how it's moving along that curved surface. Typically you see it caused by local steepening along the base of a stream. Here's another picture of a slump in Pacific Palisades, California, and you can see this area in here is your slump block. So it slid down from up here, and this area right in here is called your scarp, material that shows from as the slump slides downward. Rock slides occur when your rock moves downslope. They typically going to move along a planar surface, and it moves in the dip direction. So you can see our dip direction is shown like this. So our blocks are sliding in that dip direction. They can also occur when joints dip steeply, sorry about that, parallel to a slope. Here are some pictures of rock slides. You see in California, you can see how all the rock from underneath this house has slid downward. You also see a rock slide coming down this way from Turtle Mountain in Canada. So basically your rocks are just sliding down the hill. Now, a flow is when you have movement of a viscous fluid. It will display like a plastic movement. It can go from either very slow to very rapid. And notice it can begin as a fall or a slump or a slide, and then it can turn into a flow. So you could have a mud flow, a debris flow, an earth flow, or something known as a quick clay. So we look at a mud flow first. A mud flow is going to move very rapidly. Notice I have here about 80 kilometers per hour, pretty fast. It is composed of at least 50% clay and silt and up to about 30% water. Typically common in arid and semi-arid environments, so they're going to be triggered by your heavy rainstorms. You could also have mud flow associated with volcanic ash. Now, if you notice this mud flow right in here, they typically follow existing channels, like in this picture. A debris flow, it's compared with the mud flow, but it's larger particles. Notice these larger blocks, okay, much larger than mud. You have less water, it's more viscous, and it tends to be slower. A debris flow will rarely follow an existing channel. And then you can have an earth flow, which is slower than a mud flow and debris flow. So what happens, you get a slump from the upper part of a slope, and it creates your scarp. So you can see how this area was initially up here. It is moved down. So all this is your scarp, and it slowly moves down slope as that thick, viscous, tongue-shaped area of wet regolith. Typically common in humid climates, grassy, soil-covered slopes after a heavy rain. We can also have what's known as a quick clay. So what a quick clay is clay that spontaneously liquefies and flows like water when they're disturbed. So you have fine silt and clay particles formed by a glacier. Quick clays are originally deposited in a marine environment. What happens is your pore spaces become filled with salt water, so you're going to get the ionic bonds. Remember, we talked about ionic bonds with minerals, and that's when you have a positive and a negative coming together. What typically happens, you see an uplift of sea level, and you have fresh groundwater, reduced ions, and bonding. So it's a reduction in the strength and cohesiveness. You can see the picture shown on the right. The bottom picture shows how everything was covered with that quick clay. Another type is solid fluxion. So that is the slow down slope movement of saturated surface sediment. It's very common in permafrost areas. So what is a permafrost area? Well, it's an area where the ground is permanently frozen. Covers about 20% of the land surfaces. Sometimes the upper portion will thaw during the summer, and it flows by solid fluxion. Now, if I built a building on the ground, a building can actually thaw the permafrost, as you can see in this picture. So notice in this picture, taken in Alaska, that the settling is uneven because the building has actually started to melt the underlying permafrost. Now, creep is a very slow movement. You really can't see creep from year to year. It is most significant in terms of economic damage and the material that's moved down slope. Very common in humid climates, And basically, creep is going to involve the entire hillside. How can we recognize it? Notice your tilted telephone poles, your tilted fence, your wavy road right here. All of those are from creep. Even this crooked tree is from creep. So if you wanted to buy this piece of property to build a house, you probably don't want to buy it because of the creep. We can also have a complex movement where we have more than one movement happening in a time. So basically in this picture, you can see that we have slumping, we have a debris flow or an earth flow, all happening together, so we say it's a complex movement. Okay, this ends part 2. We will come back and start on part 3 in a moment.